Hi guys, welcome back to the vlogs.
Okay, 9.2, you're deciding if a parallelogram is also a rectangle, square, or a rhombus. Okay, so remember we had that chart of parallelograms incorporate all of these other things. Yes, we talked about that the other day. We said quadrilaterals are trapezoids, parallelograms, rectangles, squares, and rhombuses. Then we narrowed it down to say a parallelogram is a rectangle, a square, and a rhombus. Then we narrowed it down further to say that a square is a rectangle and a rhombus, right? Okay, so rectangle diagonals theorem says a parallelogram is a rectangle if and only if its diagonals are congruent. So, a parallelogram is a rectangle if and only if its diagonals are congruent. So parallelogram ABCD is a rectangle if and only if AC and DB are congruent, the same length. So if the diagonals of your parallelogram are equal in length, then you have a rectangle. Okay? Once again, you will only pass this lesson or this section of tests if you know the rules. Okay? If you don't know the rules, you're not going to be able to do anything. So if the diagonals are equal, if BD is equal to CA, I have a rectangle. The parallelogram can be classified
Wait.
as a rectangle.
Okay, go ahead.
Carry on.
Oh, it is. We have a lot of people out today.
No, proceed.
Okay. So if I have a parallelogram is a rectangle if the diagonals are congruent. Okay. So here, rectangles, rhombuses, and their diagonals. It says prove, okay, the measure of angle A equals the measure of angle B, which equals the measure of angle C, which equals the measure of angle D, which equals 90 degrees. Given that ABCD is a parallelogram and AC is congruent to BD, what do I need to start with?
The given.
Okay, let's start with the given. A, B, C, D is a parallelogram. And I'm gonna also say that AC is congruent to BD. These are all givens. So I'm gonna mark that on here. This here is the same as this here. I don't know how to mark that perfectly though. Okay, those, that looks like the segments, but, okay, the long line is congruent to the other long line. So when I do that, I know that this line right here, okay, is congruent to this line right here. What do I have going on now? I have two, well, I don't know that they're right yet, because I'm trying to prove that those angles do equal 90, correct? Okay, how can I prove that those triangles are congruent in order to prove that their corresponding parts are congruent? Well, no, we can state that using the theorem that we just learned, but yeah, you don't know that it's a rectangle until we do that. So, you wanna state that it's a rectangle? Okay, what theorem is that?
The rectangle.
So, A, B, C, D is a rectangle. Why? What was it called?
Al, can you please speak up for the camera in the back?
Rectangle
Rectangle
diagonal theorem. Yeah.
Ooh.
diagonal theorem. Okay, so it's rectangle diagonal theorem. Beautiful. So if we know it's a rectangle, what do you know about rectangles? What's the definition of rectangles?
I don't feel like flipping all the way back
I
another page.
know it.
Okay,
A parallel is 4 angles.
Four
Oh.
right angles.
a rectangle what?
4 right angles.
Beautiful. So I know that a rectangle has
4 right angles.
4 right angles. So then I can say angle A, angle B, angle C, angle D are
Right angles.
90 degrees, right angles, because the definition of a
Rectangle.
rectangle.
Is that it?
Like, you can solve it in that many steps.
Witness.
I could I could have done a harder thing. We can solve it a different way. I could say that AD is equal to AD because they are reflexive.
Reflexive.
Okay, and then I could say that BA is congruent to CD because they are opposite sides of a rectangle. And you can have side, side, side for a triangle, and then you can prove that all the angles are 90 off of that. Yes?
Your scarf and skirt are two different colors.
Yeah, they're a little off. No one cares.
Who cares?
Just
You can prove it that way. Or you can prove using, I could say that this side, AC and BD are congruent. Then I can say AD and AD are congruent using a reflexive property. And then I could say that angle BDA is congruent to angle CAD, okay? BDA, CAD, yeah, because of, I think if that's the order I want to go in. BDA, CAD, yes, that's the order I want to go in. Because you can do, what is that called? I can't think. Alternate interior angles. So you can solve it several different ways, okay? But that's probably the quickest. Okay, two more theorems. Parallel and rhombus theorems. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So a parallelogram is a rectangle if the diagonals are congruent. It's a rhombus if the diagonals are perpendicular to each other. So if AB, or AC, and BD intersect at 90-degree angles, you have a rhombus. Okay, a parallelogram is also a rhombus if and only if the diagonals bisect the figure's angles. So when it's a rhombus, it's going to do two things. It's going to create 90-degree angles where the intersections are. It's also going to intersect each angle congruently. Okay, it's going to divide angle B into two parts that are equal, angle D into two parts that are equal, angle A and angle C into two parts that are equal. So parallelogram ABCD is a rhombus if and only if angle BAC is congruent to DAC, angle ABD is congruent to angle CBD, angle BCA is congruent to angle DCA, and angle CDB is congruent to angle ADB, which gives me lots of triangles and a lot of things to work off of. And then I think we're doing one more example, and I think we're done. Pretty sure it's an example.
Is it another proof or is it like actual?
No, I think it's like math that we do.
Okay.
Because on these ones, we're gonna figure out what the angle measurements are basically, right?
Yeah, yeah.
Because if we know they're congruent, we can set them equal to each other, solve for x or y, plug back in and solve for each angle. Does that make sense? Okay. I'll give you guys a couple more seconds, and then we'll
Carly,
switch.
I really want to look up the
So for your homework tonight, you really need to know what all three of these things are. Also, if you take a look at Power School, you have a quiz on Friday over 9-1 through 9-3. So we'll do 9-3 on Thursday, and then you're gonna have a quiz over 9-1 through 9-3. If you don't know the theorems, you're not going to do well on the quiz. Okay? You need to know definitions of rectangles, rhombuses, squares, parallelograms, trapezoids. And you need to know about their diagonals, what classifies what using diagonals, okay? Okay, so here you go. This says, identify rectangles, rhombuses, and squares. What type of figures are MINE and YOUR? They are not drawn to scale. And then we're gonna start solving some stuff off after that. So what figure is MINE here? How can I classify it? Is it a rectangle, a rhombus, or a square? Why do you say rectangle? Yeah, all of these parts this part here is congruent to that part, and this part here is congruent to that part, which means this big line is going to be congruent to this big line there. So the diagonals are congruent, which means it is a rectangle. So this one's a rectangle. Okay, what about this here? Why do you say rhombus? Because it intersects angles. The diagonal intersects the angles. These symbols here tell me that this angle and this angle are congruent, this angle and this angle are congruent, so this is a rhombus. Now, if I know that those angles are congruent, what is the overall angle of angle R? Making you think a little bit. What is the overall measure of angle R? What'd you say? Why 110?
It bisects angles.
Yes, because this line here is showing that it bisects that angle, which means that this part is congruent to this part, right?
Yeah.
So if this part is 55, that means that this part is also 55, which means the whole thing is 110. If this angle is 70 down here, why? What is angle U?
70.
70. So if I drew the bisector, that would mean that these angles split into what degrees? 35. Half of 70 is 35. Okay? Those are the three things that you're taking a look at tonight on your homework. Okay? That is it.
I shall stop the clock.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Bryson?